In this demo, I'll be creating a program that implements and utilizes the from and into traits. For this first example, I'll be implementing the from trait for a new type. So this new type will be called uppercase, and it will take a string as the inner type. I'll then implement the from trait, so we'll convert from a string into an uppercase type. The from trait requires the from function to be implemented. I'll name my function parameter data, and it will be a string. It will return self, and we'll just return the new type with the data.toUppercase. So what's happening here is we're implementing the from trait, and we're converting from a string into an uppercase type. Our function parameter must be a string, which is the same as this here, and we can use self to return uppercase. We can also type uppercase here if we wanted, but I'll just refer to self. That way we can change this later if we wanted to. In our function body, we just return a new uppercase, and we take the data, which is a string, and we just convert it to all uppercase letters. So our structure here will just always have a string, and it'll always be in all caps. I'm also going to make an implementation to convert from a string slice into an uppercase type. So I'll just copy this one, and we'll change the string to a string slice, and this will just be a string slice right there. The function body is the same since we have access to the toUppercase function on both strings and string slices. In our main function, we can try using the from trait. So we'll have uppercase from, and then we can have some string from lowercase. So this is utilizing the from trait, and we're taking a string slice, which is implemented here, and we're going to convert it from the string slice into an uppercase type. If we want to utilize the into trait, we can do so with type annotations. So we'll set the type of this variable to an uppercase type, and we'll type in our string that we want to change, and we'll type in .into. So that will convert this string slice into an uppercase type. In our next example, we're going to be taking a keyboard input event and just converting it into a global input event handler type. We'll be implementing the from traits on the key event type. So we'll have implement from key event for input events. We'll implement our from function. So the event will be some kind of key event. And we'll return a self, which is an input event. We'll then just return an input event, which is a key for key events. And we'll pass in the key code and the state. So if we take a look here at our key event struct, we have a key code and a state. So the key code is just whatever code was pressed, and the state is either down or up. We might want to use something like this if we have a keyboard event, but we have a function that handles all events. So we just convert it from the key event into an event that can be handled by the global handler, and then it'll be able to be dispatched throughout the program. Down here in our main function, we have a key event present, and we'll turn it into an input event using the from trait. So we'll create an input event from a key event. So here we want an input event, and we want to get it from a key event. So this function will turn the key event into an input event. If we wanted to use the into trait, we can do so also. So we can have an input event. We have to set the type annotation. So we set it to be a type of an input event. And then we take our key event and just call .into on it. So we'll take our key event and turn it into an input event. In this last example, we'll be using the thisError crate in order to derive error for some error types. So as you can see, we're using the thisError crate, and we're deriving error on 3 different enumerations. So here we have a network error. We also have a database error. And down here, we have an API error, which contains both the network and database errors that we just created. So these are the variants here. And then these will be the types that are the inner values of these variants. Right now, if we wanted to create an API error, we would need to choose a variant. Then we would need to create a network error and place it within that variant. Let's fix that by implementing the from trait on these enumerations. That way we can just automatically get an API error from a network error or a database error. So I'll do the network error first. So we'll implement the from trait. We'll go from a network error, and we'll go into an API error. We'll implement our from function. So that'll be from a network error. Return a self, which is an API error. And then we'll just reduce self again, and we'll return the network variant of self, which is located right here. So when we have self, we're referring to API error. So this will be API error with the variant of network. And that will include our error, which is a network error. We could do the same thing for database error. So let's just copy and paste this and change it to a database error. And then we'll choose the database variant. So now we'll be able to convert both from a network error and from a database error into an API error for both of these. If we want to utilize this error in a function, we can do so like this. So we have our doStuff function, and it returns a result. The error type for this is the API error. So what we need to do in order to get an API error out of a network error is first use the ERR variant of result, put in the error that we want to return, and then use a question mark operator at the end. The question mark operator will attempt to automatically convert the inner error into the return value error. In the case of this function, we have an implementation of from up here, so we can convert from a network error into an API error. So we'll have a network error here. This will call the from implementation on network error, and it will convert into an API error automatically because we have the implementation here. There's one last thing I want to go over before finishing up. Since we're utilizing the this error crate and we're working with errors, we don't actually need to write these implementation blocks at all because the this error crate can do it for us. If we scroll up to our error enumeration and we go into the variants, we can add the from macro that's provided by the this error crate. What this will do is automatically implement this entire from block for both network error and database error. So we don't need to actually write these implementations manually. So we can just delete these. Now, thanks to the from macro, we no longer need to write those implementation blocks when we're dealing with errors and utilizing the this error crate. This concludes the demo on implementing the from and into traits. I'll see you in the next presentation.